So if we have a variable, for example x, and we raise it to a rational exponent with the numerator being 1, for example 1 over 3, what we can do is raise this entire thing to 3, which is the denominator, and we get x again because we can multiply 1 over 3 times 3 and it just turns into 1. And if we have cube root of x, which is the third root of x, we can also raise this to the third power, which is the denominator in x to the power 1 over 3, and these cancel out and we get x. So what this means is that x to the power of 1 over 3 is equivalent to the third root of x. And this works for every single rational exponent where the numerator is 1. For example, if we have x to the power of 1 over 7 and raise it to the power of 7, we get x because 1 over 7 times 7 is 1. And if we have the 7th root of x and raises to the power of 7, these two cancel out and we get x. So this means that x to the power of 1 over n is equal to the nth root of x. And this rule doesn't only work when the numerator of the fraction is 1. Since x is just a variable, we can replace it with anything else. So let's replace x with x to the power of m and rewrite the equation. So x to the power of m raised to the power of 1 over n is equal to the nth root of x to the power of m. And this simplified is x to the power of m over n is equal to the nth root of x to the power of m. So this is another one of our rules and is the general rule for all rational exponents. So for example, if we have x to the power of 5 over 6, this is equivalent to the 6th root of x to the 5. And this is also a rule where if the numerator is 1, the m here would also just be 1, but we can ignore it, so it just simplifies down to x. Now, why this is useful is if we have an expression like this, 2 times the cube root of 2, you might think that we can't simplify it further, but we just learned that we can simplify this cube root of 2 into 2 to the power 1 over 3. So let's rewrite it as 2 times 2 to the power of 1 over 3. And 2 is just 2 to the 1, so let's rewrite that, and this is equal to 2 to the power of 4 over 3. And yeah, that is how you simplify it, but also you can rewrite this as cube root of 2 to the power of 4, and 2 to the power of 4 is just 16, so this is cube root of 16. So those are two different ways to simplify this expression. Also, if we need to simplify something like this, 4 to the power of 3 over 2, we need to simplify it to square root of 4 to the power of 3 first. But also, we can simplify this 4 to the power of 3. 4 to the power of 3 is 64, so this is equivalent to square root of 64, which is just 8. So 4 to the power of 3 over 2 is 8, just by following these steps, which shows that you don't need to keep this simplification inside like a square root form or like a nth root form, but you can sometimes simplify it into an integer like we did here. And if we have something like this, 8 to the power of negative 4 over 3, we can't just simplify this to negative cube root of 8 to the power of 4. These are not equal, but instead we need to simplify it to 1 over 8 to the power of 4 over 3. This is equal to, we can just focus on the denominator, and this is equal to the cube root of 8 to the power of 4. But what I notice is that 8 is 2 to the power of 3, and I'll show you why that's important. If we rewrite it as 1 over cube root of 2 to the power of 3 to the power of 4, we can reverse the positions of this 3 and 4. So let's do that. To the power of 4, to the power of 3. And these two cancel out actually, this 3 and this 3. So all we're left with is 1 over 2 to the power of 4, which is just 1 over 16. And yeah, we're using the idea that this doesn't always have to stay in the rational form, but can instead be changed into an integer or a full fraction like this. And again, you can't put this negative into the 4 to make it negative 4th root of 8 to the power of 3. You can't do that. You have to turn it into a fraction like this. Now let's do some practice problems. If you think you know how to do this one, then pause the video and try it. This problem is asking to rewrite the 7th root of 49 in the form x to the power of n. For this problem, we can use the rule that the nth root of x is equivalent to x to the power of 1 over n. In this expression, 7 is n and 49 is x. So what we can do is rewrite it as 49 to the power of 1 over 7. And this answer is correct. However, 49 is 7 to the power of 2. So I would rewrite it as 7 to the power of 2 to the power of 1 over 7, which is equal to 7 to the power of 2 over 7. This answer is what I would write even though both of these answers are correct. Now let's do another practice problem. This problem asks to simplify 1 over the 5th root of 2 into a single power of 2. And as we stated before, the denominator in this fraction can be rewritten in a different way. And this turns into 1 over 2 to the power of 1 over 5. However, since the numerator in this fraction is 1 and the denominator is a number raised to a power with nothing else, we can rewrite this as 2 to the power of negative 1 over 5. 2 to the power of negative 1 over 5. And this is a single power of 2, so we have solved the problem. So 1 over the 5th root of 2 is equivalent to 2 to the power of negative 1 over 5. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and try it. This problem asks to rewrite 9 to the power of negative 3 over 2 in simplest rational form. Now, to do this problem, what we need to do first is put the whole thing under in the denominator of a fraction where the numerator is 1 because of the negative inside the exponent. So 1 over 9 to the power of 3 over 2. And we can rewrite the denominator into the square root of 9 to the power of 3. But what I notice is that 9 is 3 to the power of 2, and we can rewrite this into 1 over square root of 3 to the power of 2 all to the power of 3. And if we swap these, we get 1 over square root of 3 to the power of 3 to the power of 2. And the square root and the power of 2 cancel each other out, so we are left with 1 over 3 to the power of 3, which is 1 over 27. So yeah, a lot of times when you have these type of problems, you'll notice that the number that you are raising to the power inside of the square root or whatever root it is can be simplified, and you can cancel something out like I did here to make it a simple fraction or a simple integer. So everything that I went through and all the problems that I explained should teach you everything that you need to know about rational exponents. If you learned something from this video or if you enjoyed it, please consider liking or subscribing.